All right, one of the things that we can do that we haven't been able to do before is we can actually use trig ratios to find the angle. We use what are called arc sine, or you can say inverse sine. That means I'm going backwards. I'm looking for the angle instead of side lengths. And to do that, we have to make sure we can do it on our calculator. And so we're just going to double check to make sure we know how to find angles. Now notice this is like the ratio on the other side of our equation. I'll show you how to set those up in a moment. But how do I plug it in to look like this? You use your second key. Now some of your calculators are different with how they put parentheses and stuff on here. So I go second sine, so then I hit my sine, and it should show up now this -1. You guys see that? It's a little bit easier to see. All right, then you plug in what they have here. I can go second square root, and I put a 3 here, close that parenthesis or it will mess up, okay? Divided by 2, parenthesis, okay? Now, some of your calculators you can just arrow out of the radical, some you're not, so you're gonna have to come and ask if it's not working for you. Okay, so then you just plug in your stuff, you know. Make sure you close off the parentheses, right? Divided by 2, all right. Close that parenthesis there at the end, hit enter. You should have 60 degrees. Now the same process can be used with decimals or so on. So I go second cosine, if I go 0.5 parenthesis, 60 degrees here too. Tangent on this one. Make sure we're doing on tangent. Go second tangent, look at the inverse symbol comes up. Plug in after the decimal what you after the parenthesis what you have. Close it off. I should get to the nearest degree, 36 degrees. We're always going to go to the nearest degree. Now, here's the cool thing. Do not overcomplicate this. You know how to set up these equations already. Okay? We're still going to use, and now I'm going to write it a different way this time to see if you can see which one works best for you, sine, cosine, and tangent to figure it out. I have to decide when to use it. So like here on this first one, if this is the angle I'm looking for, that's my opposite leg, this is my hypotenuse. So to figure it out, I'm going to go, all right, opposite and hypotenuse is sine. So I go the sine of x degrees equals 4/5. Notice my setup of the equation is the exact same process we're doing before, except for what's missing is the angle. So then I do the inverse. Okay, and the inverse would be of 4/5. Okay, so I go second sine basically, 4/5 equals x. Now I have to enter it into my calculator. Now this is going to be to the nearest degree. We're going to have to round. So we go clear that so you can see what we're doing here. We're going to go second sine 4 divided by 5. I'm going to let the calculator do the work, and I get this to be 53 degrees. But I need to see that second step. It is critical. I need to see 1, 2, 3 points each. Okay? Now let's get the next one. For this angle, what sides are we talking about? Okay, we have our opposite, and this is your what? Hypotenuse. So I'm going to set it up the same way. I'm going to go sine of x equals opposite over hypotenuse. Now someone goes, ooh, reduce the ratio. Normally I say yes, reduce the ratio, but the thing is I'm punching it all into my calculator, so it doesn't make a difference, and that's not even my end answer. Does it make a difference if I simplify the ratio? No, so I'm not going to do it this time. So now I have to write in that I'm looking for the angle instead, so I do the arc sine or inverse sine, go 6/9 equals x. Now look what we're going to put in there together, so let's clear this off. Okay, go second sine 6 divided by 9 parenthesis. What do you get? To the nearest degree, I look at the decimal, I round up. So x is approximately 42 degrees. 3 steps, same process. All right, now for time-wise, I'm just actually going to give you an example of each one because these are just repeating the process. Again, look at the angle if you can. I'm going to clear this calculator, it's driving me nuts. Okay. For this angle, I realize that's the adjacent leg and that's the hypotenuse. Now remember, we have katoa. All right, which one has adjacent and hypotenuse? Cosine. So I go cosine of x degrees equals adjacent over hypotenuse, 8/18. So then I can use my inverse function to find the angle because that's what I'm looking for. So second cosine, so our inverse, our arc cosine, of 8/18 equals x. Second key, cosine, and just go 8 divided by 18, close that parenthesis, enter. X is going to be 64 degrees, approximately, because we're going to the nearest degree. What do you guys think? Yeah, not too bad, is it? All right, let's look at another one. So that's using cosine. Now let me do the same type of example of working with tangent here, okay? So with this one, oops, clear. Notice this is our angle. I still look at the angle and I realize that's opposite leg and this is adjacent leg. Not using the hypotenuse, so that threw out your other two options. So looking at this, I go, okay, which one? Sine, cosine, or tangent? Well, opposite and adjacent is tangent. So I go the tangent of the angle, so tangent of x degrees equals opposite over adjacent. I just said hypotenuse. I'm so sorry. Adjacent. So then I do my inverse tangent to find the angle, because I'm not solving for side, I'm solving for angle this time, equals x degrees. And x is approximately, well, let's put this in together and find out what we get here. Second tangent. And what do we have? 8 divided by 10. Parenthesis equals, round up, it should be how many degrees? 39 degrees. Excellent. Now guys, you easily can do these. Notice there are 3 steps. If you put your, seriously, the problems with you and you have your notes, you should have no problem getting these.